Okay, so in this video we're starting section 5.2, which is qualitative analysis and nullclines. Now, nullclines are just going to be the curves where x prime equals 0 or y prime equals 0. Okay. And a curve is just a one-dimensional object, so a curve that doesn't curve is still called a curve, we just call it a line. So it could be lines, could be curves, but these are going to be the places where one of these derivatives is 0, but not necessarily both. So in the last section we were focusing on equilibrium points. That was where x prime and y prime were both 0. Those would be points that by themselves were solutions, and the significance was that if we were able to linearize the system near those points and classify those points, then we knew how the system behaved near those points. This information is going to give us some information about how the solution curves behave anytime either one of those derivatives are 0. Okay. So, if I want to try to calculate those, I'm going to just take this here. I've got f of xy is the formula that's giving me x prime. I'm going to just distribute this 4x first. So I'll get 4x minus 2x squared minus xy. And then that will allow me to factor out an x from every term. So I'm getting x times 4 minus 2x minus y. So if I were to look at my x-nullclines, that just means that x prime is going to be 0. So one of these two things will be 0. So either x equals 0 or 4 minus 2x minus y equals 0. And I'm going to draw in those lines in my phase plane. Now if I look at this system is meant to represent competing species. If I ignore the xy term, I can see that both x and y are growing according to a logistic growth model. And then if I don't ignore that term, I see that they're both hurt by xy interactions. So if I'm thinking of these as species, I'm going to just draw the phase portrait in quadrant 1. So we're supposing that x and y are both bigger than or equal to 0. If I were doing this as a pure just math problem, I could, of course, I've got a hair in my face. I could, of course, work with the entire phase plane. I feel much better now. Oh, okay. All right. So if I look at x equals 0, I know that's just the y-axis. So the y-axis is going to be an x-nullcline. That means x prime is 0, so that our curves aren't going left or right. Now, if they're not going left or right, all they can do is go up or down. So I'm putting some little vertical marks here to indicate that the tangent lines along the y-axis have to be vertical. Now, it's hard to see because I've drawn the y-axis in, so I'm just going to make a note that this is the x-nullcline. I will point out, you want to be careful. We see x and we associate that with horizontal. But if x prime is 0, that means we have a vertical tangent because we are not moving in the x direction. Okay. So the other places I have that would be here. If I solve for y, that's going to be y equals 4 minus 2x. So let's see, that's just a line of intercept 4. X-intercept will be 2. I'm going to draw that in. There's my nullcline. Okay. Ooh, these tick marks make it look like the tangent line is horizontal, so let's not do that. Okay. Now, I'm not claiming that's a solution curve. That's a nullcline. And again, if it's an x-nullcline, I'm just going to put some little vertical tick marks here to indicate that the curves have to have a vertical tangent if they're crossing that line. Okay. All right, let's do the same thing for our y-nullclines. So I'm going to take g of xy, which is the function giving me y prime. I'm going to distribute that 3y. So I'm going to get 3y minus y squared minus xy. And then I can factor out a y, so I get 3 minus y minus x. So if I look at my y-nullclines, I'm going to get y is equal to 0, or 3 minus y minus x is equal to 0. Now y equals 0, that would just be the x-axis. So now I know that the x-axis here is a y-nullcline. So y prime is 0, so we are not going up or down. And if we're not going up or down, that's going to mean that we're going to have horizontal tangents. So again, because it's hard to see here, I'm going to just make a note that the x-axis here is a y-nullcline. Then here, this curve would be y equals 3 minus x. So that's going to be a line that comes like so. And I'm going to just put some horizontal tick marks along here to indicate that we would have to have a horizontal tangent there. Now, what's really significant is these nullclines are the only places that my solution curves can change direction. Because if I take a look, my derivatives are continuous and always defined, so the only time a derivative can change sign is if it passes through 0. But if I had a curve and I wanted to change from going to the right to the left, I'd have to have a vertical tangent somewhere. That can't happen except at points on this nullcline or on this nullcline. Okay. So knowing where the nullclines are is very significant, because that's where the curves could change direction in either the x or the y-axis direction, depending on which type of nullcline it is. But also I know that my curves don't change direction anywhere else. Okay. Now if I take a look, my nullclines touch each other sometimes. There are some places where my nullclines intersect. Oops. This was a y-nullcline. Okay. Now if I take a look here, the y-axis was an x-nullcline. This pink line here was an x-nullcline. So that's two x-nullclines intersecting. That tells me that x prime is 0 and x prime is 0. So I'm really confident here that x prime is 0, but that's all that that tells me. But if I look here, this line was a y-nullcline, and this line was an x-nullcline. So at this point right here, I know that both x prime and y prime is 0. That's going to be an equilibrium point. Okay. So the equilibrium points occur when an x-nullcline and a y-nullcline intersect. And this sort of gives us a geometric way of thinking about finding the equilibrium solutions. When we found the equilibrium solutions in the last section, we thought of it more algebraically. We said, well, in order for x prime to be 0, either x has to be 0 or this factor has to be 0. Well, what that means geometrically is we're either on this x-nullcline or we're on this x-nullcline. Same thing for the y primes. If y prime is 0, either y is 0, we're on this y-nullcline, or 3 minus y minus x is 0, we're on this y-nullcline. Okay. So if I look at this point right here, I can see that is the intersection of an x-nullcline and a y-nullcline. That's where we're on this line, which is where 4 minus 2x minus y is 0, and on this line, which is where 3 minus y minus x is 0. Okay. Now, if I wanted to find that, because that's an equilibrium point, I would just say, okay, so y equals 4 minus 2x, and y equals 3 minus x. So 4 minus 2x equals 3 minus x, 1 equals x, and then I plug into either equation and get that y is equal to 2. This point, of course, was the y-intercept of this line right here, so that was 0, 3. Now, if I look at this point, this is a y-nullcline intersecting another y-nullcline. That's not an equilibrium point. If I look at this point, I've got an x-nullcline intersecting a y-nullcline. And having those little vertical and horizontal tick marks is really helpful, because I can see I've got one of each at this point. So this is an equilibrium solution, and it's where this line, which was 4 minus 2x, hits the x-axis. So that's going to be when x is 2. So that's the point 2, 0. And then I want to remember that the x-axis was a y-nullcline, the y-axis was an x-nullcline. They, of course, intersect at the origin, which is also an equilibrium solution. So those are my 4 equilibrium solutions, and it's kind of nice to see how the geometry of these nullclines intersecting coincides with the algebra of one of these factors being 0 for each one. Now, what we'll do in the next videos, we'll pick up with this and see how we can use this information to try to start sketching a representative phase portrait for this system.